All right, you guys. So let me go over to what you're reading. And hopefully yours is not as slow as ours and it's getting over there soon. Okay, good. All right, so let's see. Emma, did you get a chance to read that? Hello? I don't know what happened to Ryan. Ryan, if you are still in the webinar, okay, well, I'll explain it, Emma, don't worry. But Ryan, if you're still in the webinar, if you could type something in the chat, that would be great. Or I see you there, but I haven't seen you respond. So, oh, all right, you guys, hang on one second before we get started. I'm just doing a webinar, but.
Yeah, I was just watching.
Oh, okay. Go right ahead. We just started, so I figured I could pause. All right, you guys, sorry about that. Okay, Emma. So we're going to go through this. Jazz, did you understand? You kind of understood it because you were talking about it. Okay. So basically, you guys, we've been studying standard deviation, so I wanted to put this on there because it was a great example of everything that you've been studying. I just read this actually in a news article, and so I thought of you all. But the key thing, so obviously this is talking about heat and the fact that the Earth is warming up is what they're saying. And if you look down about the second paragraph, and let me, whoops, move this around. Maybe not move that around. Let's get to a red. Maybe not. So if you guys look down here on the second paragraph, down in here, seem to be on the highlighter function. I don't know why. You'll start to see where it talks about standard deviation. So what they're saying is that, and it's highlighted in yellow, that they define extreme heat waves as those in which temperatures reach 3 standard deviations above the historical average. And if you guys remember your standard deviations, that is usually where the outliers start to fall, right? Because remember, most of your data falls within 2 standard deviations of the mean, which is that 95%. And then even more alarming, if you look over at the very bottom down here, the very bottom, they project that temperatures 5 standard deviations above the average will occur in 3% of the world. So hopefully we are not living in that 3% of the world, right? So I thought that was really just very interesting and an example of how standard deviation really is used. So let's actually graph this out. All right. Make sure no one else is on. Okay. So let's actually, just because I want to make sure you guys understand a little bit about how these graphs work. So one thing that's really important to know is that the left side, the y-axis, is always your, oops, come on. No, I don't want that. Having a little problem here, you guys, trying to get my colors. So let's just move this. Well, I guess we can't really move it. Okay, we'll stay with blue. So anyway, over here, this is your frequency. So this is how often it occurs. And then always on the bottom, it's what you're measuring. So in this case, we're measuring temperature. So let's just say that our average temperature is around, I don't know, we'll say 75 degrees. And I'm just making this up because it didn't say in the article what our average was. Okay. Then what we're saying is that that occurs annually the most frequently. So maybe that's somewhere up here, like maybe that occurs in the course of a year, maybe that occurs 100 times. Oh, hang on. We must accept Melissa in. Okay, so if that occurs 100 times, that's the most frequent. And then maybe some other temperatures down here occur less frequently. So if we were to draw a normal distribution, say that it's normally distributed, and actually it probably is if they're talking about standard deviation, because usually we don't really look at standard deviation unless it's normally distributed. Oh, here we go again. I don't know why this keeps opening up. And so let's actually pick another color. So how about let's just say then, so 75 is our mean, and again we're making that up, and let's just say that our standard deviation, remember this is a symbol we use for standard deviation, we'll just say it's 5 degrees to make it easy. Okay, so if we go up 5 degrees to the right, that is now 80 degrees, right? And that's one standard deviation to the right. If we go down 5 degrees, that's 70 degrees, and that's one standard deviation to the left. So I can draw these little bars up here against my graph, and you guys saw this week when you were going through your lessons. And Jazz, you just learned that today. Very nice. It's totally good. Oh, there I go again. Keep pushing the systems. I think what it is my screencast-o-matic is, I just need to move it down a little bit. There we go. Okay, now let's try hitting the buttons. Oh, see, that button just wants to go. So then our mean is right here in the middle. Somewhat straight. Okay, so really important thing to know is that between these standard deviations, that represents 68% of all the data. Okay, that's one standard deviation to the right and one standard deviation to the left. But we can keep going, okay, because that's obviously not all our data. That's only 68% of our data. So if we went up one more standard deviation, hopefully you guys saw this on the recordings, and you go down one standard deviation, well, let's actually put markings there. So that would represent 65 degrees if we went down one. And if we go up one, that represents 85 degrees. Okay, well, just so you know, that total is 95% of the data. That's a lot of data. Okay, so that means that most of the temperatures are going to fall between 65 and 85 degrees. So that's 2 standard deviations right there, right? This one out here, this is +2, and this one right here is -2. So this article is talking about 3 standard deviations above the mean and 5 standard deviations above the mean. So I'll change my color. So think about if we went 3 standard deviations above the mean. That would be, what, 90 degrees?
Yeah.
Yes, very good, Jess. Yes, 90 degrees. So now think about if that suddenly becomes our average. That's pretty hot, don't you guys think? A little bit hot?
Yeah.
Yeah. Now, if we think about 5 standard deviations, okay, so going up to 90, that was 3. If we think about 5, what temperature are we going to be at?
No,
100, good, because 4 is 95 and 100 is 5. So 3% of the world potentially could be as hot as 100 degrees. I mean, assuming that we have the right mean and the right standard deviation, which they didn't tell us that in the article. I just thought that was really interesting, and I just wanted to map that out for you guys so you could see what that looked like exactly. So when you get problems that say, what is the range of 68% of the data? You just need to start with the mean, subtract 1 standard deviation, and add 1 standard deviation, and then your range would be 70 to 80 degrees, right? That would be 68% of your data. If the question asked you, and I know you had some quizzes that way, that said, where is 95% of your data? Again, start with your mean, but this time subtract 2 standard deviations to the left, and then add 2 standard deviations to the right, and that is where 95% of the data is going to be. All right, you guys, any questions? That was just a little bit of a review for you all. So, Jazz, you're good. And you had a nice review today. So, see, double review. Perfect. Emma, how are you doing? And Emma and Melissa. Good to have you guys. And Ryan. I don't know if you're back yet, but oh, good. I'm glad you're understanding it more. Perfect. And Melissa, how about you? We haven't heard from you. Just want to make sure you're comfortable with the chat box. And Ryan, if you guys are here, say something in the chat, you know. See yes if you're good, or yes if you have questions, I guess, or just say I have a question. Or all right, so maybe Melissa and Ryan are MIA at the moment. Hello. Are you coming for a webinar? Oh, perfect. Perfect. Well, you can just.
We go get it.
Core 3. Yep.
We go get it.
Awesome. All right. So, guys, let us continue on. If there's no questions. Okay. So starting the, yeah, you can just actually listen, Donovan, and then when you get to your computer, you can log in, you'll be fine. Yeah. So you missed our little preview, but I can go back over it with you too. So it's all good. Okay, so you guys, by the end of this week, and this is not what we're doing all here today, but if you have a calculator, you might want to grab it. If you don't, it's okay, because I have the calculations too. I did them in advance. Hopefully they're all correct. You guys won't be able to check me if you don't have a calculator, though. Jazz has a calculator. Very good. So this week in Core 3, in Week 3, you will be able to, actually, it's kind of an interesting one because you're going to look at surveys. So you're going to be able to list the steps in the survey design process. You will look at some really interesting videos actually back at the time of the draft, the Vietnam draft, and you're going to look at random sampling and sampling bias and some stuff with elections, so that's going to be interesting. Then you'll also be able to list and describe some different sampling methods, because there is more than one, believe it or not. And then you do have a little bit of math, of course, because this is math. I know. It's all the math. You are going to have to calculate margin of error, but it's pretty simple. It's not too bad. Going backwards, maybe, and we're going to actually do that today, so you'll see it a little bit, so you'll understand it. And then, and we're not doing this in here, but you'll want to calculate and know the meaning of a z-score, and a z-score is actually easier to calculate than margin of error. You did go over z-score? Oh, did you go over it from Week 3, or were you just?
No, it's like a Week 2, and I just went deeper into it. Because I wanted to understand it more.
Excellent.
Better,
Yes, very good. So Donovan is here, and he's already looked into z-score. So excellent job, very proactive. Good, good. So anyway, you guys, so we will be doing a little, like I said, margin of error today, but I don't want to be going overboard and bore you guys in too long of a lesson. So let's just do this, and I want you guys to chat with me on this. So I just have 3 questions for you, and I want you to think about this, okay? So you're going to sample 100 random people that are shopping in the mall. Okay, so you go to the mall, you sample these people, because what you want to do is determine average household income, because you're just curious what the average household makes. So you're going to sample these random people. What do you think? Will your results be representative of Colorado, the state of Colorado? What do you guys think? So like you can't sample everybody in the state of Colorado, right?
Yeah, that's right.
I mean, that would take years. And you probably miss somebody because there's somebody living in a tent somewhere that you're going to miss. Or they're hiking on the trail. So you guys are just going to sample 100 people from the mall. That's where you choose to go because you figure people come to the mall, so I'm going to sample 100 people. So let's say you sample those 100 people and you find out that their average income is $60,000 a year. Could you apply that to the state of Colorado? Do you think that's representative, that represents the average income in Colorado? What do you guys think? No. So I'm getting a no here in the classroom. Emma, what do you think? And Melissa, if you're back, tried to get a hold of you earlier. Oops, oops, hitting all kinds of buttons over here.
You've been doing that all this time.
Have I? Oh, Melissa's coming back. Ah, that's why. All right. Okay, so Emma, oh, I thought you were typing, Emma. Emma. Okay, so we've got a couple notes here on question 1, but Jazz and Emma are typing. Excellent. Melissa, if you just got back, what we're doing is we are answering question number 1. Oh, yes, you were the one that said no. See, very good. Are you good with the chat? Do you know how to do chat too? On the, oh, you haven't logged in yet, have you?
No, I just got the thing wrong a couple times, the password, but yeah, I'm going in.
Okay. Okay, you only have to log in as a guest, just so you
They
know.
have new computers that you're using.
Really?
It's over there. It's over there.
Oh,
Yeah.
I have to check that out.
All right, so we'll just wait on Emma for a minute, and then Melissa, if you are here, do you think?
I'm kidding.
What do you think if that would be representative? All right, Emma can represent Colorado as a whole because of all the other people who are surveyed the most. Okay, so I see your logic. I see your logic. Okay, type in one more. All the 100 people who are surveyed. I'm having a hard time putting into words. Oh, that's okay. That's fine. And also, Emma, if you like, I can, if you have a microphone, I don't know if you do, but you probably need like a headset with a microphone.
Um,
Um,
is she have like a little PC thing,
oh yeah, if you're at home and you have a PC with a microphone, that would work too. I can always enable your mic if it's easier, but you know, just typing is fine too. But anyway, so Emma is right. I mean, right, of those 100 people that you surveyed, when you guys say, I mean, that was their average income, right? $60,000. But then, so she's right about that.
Well, yeah, and you got to depend on the environment that you're because not everybody goes to mom. Super
This is true. So what Donovan is saying, because he's not totally logged in yet, but he's saying that depends on the environment because not everybody goes to the mall because the mall is super expensive, and that is exactly my point. Oh, here he is now. Oh, okay, Donovan, I'm trying to accept you. There we go. All right. Ah, yes. Okay. Okay. So at least you're in now, Donovan. Yay. Okay. So see, now you guys have to type so everybody can hear you guys. So, but anyway, so it would just be the population in the mall. Exactly, Emma. Exactly. So when you find that 60,000, it's really just going to be the population in the mall, and you don't really know if that's everybody else. And so that's the hard part. And if you think about it, and Donovan had a good point before too, is he was saying, hey, you know what, things in the mall are kind of expensive. And if you don't make that much money, do you think you're going to go to the mall very often? No. So
maybe the flea market.
Maybe the flea market or something. And again, if we surveyed only people in the flea market, we wouldn't really be getting a representative sample either, just because those people might not be making a lot of money. So the hard thing is, you guys, is coming up with a sample of people that really represents what you want to do.
And choose the perfect environment too, right?
Yes, and the right environment, making sure you're in the right place. And that's actually really important if you guys go into business and stuff and you have a new product and you want to see if it's going to sell, or you're doing a business plan, and so you do samples, you know, but you got to be careful who you do your samples with, and you got to be careful about, you know, how many people you sample to make sure that it really does represent what's true. Okay, so you guys, let's actually look at this second one real quick. Or, yep, right, Emma, or wherever you survey the people exactly. You guys are on the same page. So if you flip a coin 10 times, okay. Now, first of all, it says, will your results be representative of the theoretical probability? Well, I bet you guys don't know what. Yeah, I was going to say. Probably don't know what theoretical probability is. Well, here, let me give you an example, okay? So if you flip a coin, what are your two choices?
Heads or tails?
Heads or
50%.
Good. 50% heads, 50% tails. And you know that to be true, right? Because you only know the two choices, right? If you roll a dice, what are your choices?
That's about 20. Six divided by.
Okay, good. Emma said 6 numbers or sides, right? So there's 6 choices. And Donovan's trying to calculate the percentage, and that's exactly right. You know what it is. So let's go back to the coin. If we flip a coin, that means half the time we're going to get heads, half the time we're going to get tails, right? Okay, what we're going to do, you guys, is we're actually going to flip a coin.
You can flip it right now.
Believe it or not, this is pretty amazing. So here we go. We're going to flip it. So somebody keep track, okay?
Okay.
All right, so I'm going to flip it. Okay, we got a tails. So do tails. Okay, I'm going to flip it again. We'll do it 10 times. Got heads. Another head. Actually, no, it's keeping track below. Thanks though, guys. Okay, sorry. So we got 5 flips. Yeah, if you look below. 6 flips. Can you hear that sound?
No, I don't hear nothing.
Oh.
It's because mine's muted.
Oh, see, it's actually okay. You ready, guys? Here we go. Because there's only 2 more flips. So there. Oh, did you hear that?
Did you flip it?
I did. Okay, I'm gonna flip it again. 10 times. Oh, so look at our results, you guys. 6 heads, 4 tails. So is that really representative of our true? No. Oh no, I did not.
Oh, okay. Yeah, I
Yeah,
see
see what I mean?
So heads won. I knew it. I knew heads was gonna win.
No, you guys are. Yeah, I mean, think about it. What should we have gotten?
Like 50-50.
50.
Yeah, and then
Yeah.
I don't know how to explain it.
50, no, you're right. 50-50 chance. We should have gotten 5 heads and 5 tails because that's what we call the theoretical probability, quote unquote. So,
Okay.
fact is that that's what we should have gotten. We didn't, and that's because, you know why we didn't? Is the why?
The flipping coin.
Well,
We did it.
we'll just pretend like that was truly a random coin, which I'm sure it was. Does anyone know why? Or how could we ensure that we could get half heads and half tails? Does anyone have any idea?
Change the number of. Oh, change the number of the amount of times you flip the coin.
Ah, very good. So Donovan said change the number of times you flip the coin. That's exactly right. And that's just something we call the law of large numbers. You don't have to write it down, but what that's saying is that if you're going to actually do a sample, you better make sure you get enough people in there or enough flips in there so that you get to the real probability.
That's right.
That's all they're saying. Because if you only flip a coin twice and you get heads both times, is it 100% chance we're going to get heads? No. So just make sure you, whatever sample you choose, that there's enough people that you're sampling or enough things so that you get a representative sample.
Probability.
Yes, exactly. And actually, that goes along with margin of error, which we'll talk about very soon. Okay, you guys, last one. So you sample 300 students at a high school with 500 students. So the high school has 500 students. And you sample them as they come in, okay? And what you're trying to determine is who they will vote for as the student body president. How about that one? Will that work? Will you get a representative sample?
Yeah, it's pretty much the majority of the school. Yeah.
Okay, so Donovan says majority of the school.
And it depends
Yes.
on the students who want to go there.
Okay.
To vote.
Emma, what do you think?
Oh, I just totally zoned out. What happened? What was the question?
We're doing number 3, Jazz.
Oh.
It's okay.
300.
It's okay. That
My
happens.
bad.
As long as I don't zone out, that's probably the good thing. Since, you know. Emma, I thought you were typing.
What did you say?
This is
So,
300 students at a high school with 100 students.
Emma, what do you think? Do you think,
She asked if they would work, and I said yes, because it.
here, you know what you could do actually, Emma? There's a little guy at the top of your screen with his hand up in the air. Can you see that? If you, oh, very good. You raised your hand. Awesome.
I'm gonna raise my hand.
So yeah, you guys can raise your hand. I think there's a yes or no and stuff like that too.
I agree.
Oh,
So if you agree that that is representative, go and hit the agree thing.
Oh wait, I
Do
don't
you guys
know.
see it? Ah, okay. So Emma raised her hand, so she agrees. Very good. And I think there's some other options. Do you guys have some other options up
Yeah,
there?
like laughter.
Okay, no. Oh, there's a check mark. Very good. So you guys found the check mark. Excellent, excellent. Okay. So exactly right. You guys, and you're on the right track. I mean, you're in the right place, right? You're in the right environment because you're checking within that school to see who they're going to vote for. So you wouldn't ask people in a mall because they don't know what you're talking about. And you're definitely asking the majority of the students, right? 300 out of 500 is a lot of students. So you probably have a good shot of having a representative sample there. All right, so just something to think about, you guys. And like I said, when you go into this week, you'll have some cool videos to watch and give you some more stuff to think about. So let's go on to a little bit of math. We were actually just going to do margin of error. Very crazy. It looks like a crazy equation, but it's actually not too hard. That is the equation if you guys want to write it down because you will need it in your homework. And of course, this is all in the work of the week, so you'll be able to see it there too.
Will it be able to decode what the symbol actually means?
It'll tell you. Yeah, it's pretty good,
It'll,
but
help me every day to watch.
it'll help you every day to watch it.
No, you're gonna help me every day.
Oh, I'll help you every day. So I can help you guys. But anyway, so this margin of error, you guys notice that there's a times 100 at the end. And the reason that we do times 100 at the end is because when you do 1 divided by the square root of n, and n represents how many people you sampled. So actually, let's just do this. So n is equal to the number of people sampled. Okay. So if you do 1 divided by the square root of n, you're going to get a decimal. And if you multiply a decimal by 100, you get a percent. So the only reason that we multiply this equation by 100 is to turn it into a percent, because we always think of margin of error in terms of percent. So margin of error will actually be a percent. Okay. So below here is kind of you need to understand really what it's about. And I'll show you guys some margin of error in some political polls that were taken in a minute. But it represents, it says here, the approximate amount of variance you can expect if you ran the same poll with a different sample. So what's that saying, like in easy terms, is that if I took a sample, like look down below here, it says, suppose a poll shows that 40% of people will vote no on some proposition, some bill or something like that, right? Maybe to raise money for school, 40%. But then they say that the margin of error is 4%. And usually you guys will see that as plus, and it's not written here, but plus or minus 4%, which means that 40%, it could be an error depending upon your sample. Maybe you didn't sample enough people, maybe you didn't get people from the right area. So really what that's saying, and if you look down below here, and I'll do this one in red, that actually 36 to 44% is really the accurate number. And maybe that's not such a big deal, but if it was really close, like, hey, 51% of the people are voting yes and 49% of the people are voting no, and your margin of error is 4%, then you really don't know, because it means that it could swing either way. Okay, so that's really just what it means. All right, so let me show you guys some polls. So here was a poll. This is an actual poll. This is the presidential choice of likely Minnesota voters. And if you guys notice down here at the bottom where this arrow is, it tells you that the margin of error is plus or minus 5.3 percentage points. So check this out. Okay, so if you look at the voters up that were surveyed between September 29th and October 1st, you have 47% that said they would vote for Obama, good, and 43% for McCain. Well, if the margin of error is 5%, do you know for sure that Obama's going to win on that poll?
You don't know for sure.
You don't know for sure, because that 43, just to write it out for you guys, that 43% could actually be anywhere from, what's 43 minus 5? 38? Could be anywhere from 38% to 48%, right? So if you look at what Obama had, 47, he's in that middle, so we don't really know for sure. Now, if you look at the bottom one, that one's pretty obvious, right? Because even if you add 5% to 4, you're not getting to that 54%. Okay, but also remember that that 54% could swing down 5% too. So that's really how margin of error works. So when you guys see these polls, always look for that margin of error to see how accurate they really are. Here's just another couple that I found. This is some research, and you guys can see the margin of error is always listed down here at the bottom. Plus or minus 3% on this one. And on this other one, it says plus or minus 5 percentage points. So 5 is actually sort of large in reality. And if you look at Fritz and Nolan, they're definitely within 5%. So sometimes you have to be careful, because these results may not actually, turn out based on that margin of error. All right, you guys. We're going to do a little calculations. Is everybody ready? Yes. You guys are. Woo, yeah. Okay. Let's do example 1. And again, you guys, there are some of these obviously in your lesson, so if you don't catch on now, there's another demonstration. You guys can watch this too. Okay, so we want to find the margin of error for a sample of 400 people. Okay, so remember that to find the margin of error, it's 1 over the square root of our sample. What's our sample?
That little
That little box thing that I just drew is a square root symbol. That's not showing up yet, but there it goes.
And then.
Oh, square.
So what goes in there?
About 400.
Okay.
Jazz, are you good?
I was gonna say something that I forgot.
Oh.
And you can always type it too. Then I can look over and see like, oh.
Oh yeah. Said it.
400.
Yeah.
So
you were right.
So do you guys see that 400 in there? So that's my sample, right? And this whole equation is going to equal the margin of error. So That's all you have to do, and then we have to solve it. So I bet you guys
So
probably
it's
want to know how to do
1
that.
divided by the square root of 400 times 100.
Exactly right. So what is the square root of 400? Mental math.
Oh God.
Mental math. You guys want to,
It's hurting already.
does anyone know?
What's the square root?
Emma, if you know, feel free to type it in. We're all thinking over here. Oh, Emma's typing.
She won.
Who is going to win this?
I'm still saying.
I don't know. I'm rusty with this stuff. Okay.
So
Well,
you said what's the square root of 400?
a square root of 400. But you guys, I'm gonna give you a
just
hint.
grab the square root because if I can.
Oh, you want to know how to do
Okay,
it.
yeah.
Okay, so here's an example. The square root of 9 is 3.
See, it's
Oh,
divided
so 400 is.
the most quantities, right? I don't know.
Square root of 16 is 4. How about,
Oh, I get it now. You got it. Yeah,
you got it?
I just
Okay.
don't know what the 400 is.
All right, here, I'm going to give you guys this. What's the square root of 4?
Yeah, two.
Ah, very good. Everybody said 2. Yay. So if you think about this, this is 400, not 4. So actually the square root of 400 is how much?
100.
Oh, you guys said the square root of 4 is 2.
Oh my gosh. Okay.
So Emma said 200, which you're really, really close, Emma. It's just that when square root happens, the zeros become like 4 zeros. So you're just like almost there. There's definitely a 2, right? We just have to figure out how many zeros.
20, right?
Oh yeah, this is 20.
20, yay! You guys, good
Well,
job.
you said it, I
I know, you guys said over here, and Emma got
I was
20.
thinking about it, like,
Nice job.
How many zeros? It has 2. It can't be 2,000.
And you guys, I'm gonna alleviate your pain. You can always use a calculator. Okay, just so you know, calculator's allowed. So now we have to figure this out. Well, we have 1 over 20 times 100. So I find it easier just to do, since 100's on top, right? It's like having 100 over 1. So I find it easier just to do 100 divided by 20 then. And so you can get rid of a couple zeros, and you get 5%.
so that's the margin of error.
That is our margin of error. And you guys, when you write it, you should really write plus or minus because it can go up 5% or down 5% from the.
How are you writing? This is weird.
I have magical writing powers, Jazz.
Haha.
Yes. All right, you guys. So we want to do the last one?
Yes.
Okay, we're almost done. We'll do this one, and then we're gonna go backwards, and we'll be done.
I thought it was supposed to only be one, and then
Yes. Well, I just want to make sure you guys are like super good at this.
oh,
Understand.
Super amazing.
Elaboration.
All right. So how about this? You guys did pretty good on the last one. You want to try this on your own? See if you can who could type in an answer. You guys can do this because look, I did the square root of 16 down below.
I did.
Mm-hmm. Mm.
I wrote.
You did? Oh. Okay, so you got the square root of 1600. Very good. So we'll put that down there. Okay, awesome.
There you go.
Of course, you're not quite done.
Oh my god.
Alright, so 1 over, no, 100.
So we have to divide that, right?
You
The
must.
100 over 40.
Yes, perfect.
And that is.
Running out of room. 100.
It's going to be a decimal, right?
Well, because we are multiplying by 100, we won't end up with a decimal.
Yeah.
But you guys can eliminate some zeros, right? What's 10 divided by 4? Let's reduce it. How about that? So if we reduce 10 and 4, 10 over 4, what do you get? What goes into 10 and 4?
2.
2, good. So 2 goes into 10
I was right. I can't believe I suck at that.
5 times. No, you did good. And 2 goes into 4 2 times. So now you guys have 5 over 2. What's 5 divided by 2?
10. No.
That's times.
No, 1.
8. No.
2.5.
8.
Oh,
Is
I heard it.
2.5?
2.5.
What the heck? Why? See, I
Okay,
think
so
it's
Jess,
tough.
here's
I
how.
don't know. I went to divide.
Well, let me type in this. Hold on, hold on,
It-
hold on.
You guys, you know, it's okay, Jess. You can use the calculator. It's totally fine. So remember, plus or minus 2.5.
Okay.
Perfect. All right, how do you guys feel about margin of error, calculating margin of error? Oh, very good. Donovan, it's okay?
Are we done?
Almost done. Almost done, you guys. Hang in there.
That's
Last
okay.
slide. You ready?
More elaboration, the more
Oh my
I can
gosh.
Okay, so I just want to show you how to go backwards because you do have some quiz problems on this and people always get confused.
Alright.
Okay,
More.
and so just a tiny bit more. Okay, so this time, look what you're given, you guys. You are actually given your margin of error, plus or
Hold on.
minus 4, right?
Backwards. Hold on. Go back to the other one. You take the notes.
You want me to go back to the other one?
Yeah,
I
don't
can.
see how to do that.
Okay. All right, we're going to go back to this one really quick just so that you guys can take notes if you want to. Oh,
Why aren't you
Emma, you're
taking
good? You got it down a little? Okay, if you need to write it down, feel free to write it down. The key for you guys here is knowing the equation. So if you know it's 1 over the square root of n times 100 equals margin of error, and make it an equation because sometimes you might plug in something in your margin of error, and so you want to make sure you have that equation. And I'll write it up here again for you guys. So it's 1 over square root of n times 100, and that equals the margin of error. And that's how you figure it out. So this is a very simple way to do it. Statistics can definitely make this more complex, but we don't have to do that. We can just do a simple, quick method. So really, if you think about this margin of error, you guys, it all depends on your sample size, right?
I'm like doing like just like a random problem on top of your head. Just like I don't know, just figure out like a couple numbers.
Oh, and then do one?
Yeah.
You want me to do another one?
It's like so everybody can
Okay.
have a better understanding of what's going down.
Yeah, so like so just kind of like these, if you sample, and I'm just going to pick a number that is where there's an easily found square root. How about like 9? What if you sampled 9 people? That's not very many, right?
Yeah.
So if you sampled 9 people,
Oh, that's so easy.
yep. Okay, so well here, we'll go down a little bit here. So if you did sample 9 people,
Okay.
well, you would plug it into this formula, square root of 9, and then times 100, right?
And you could can't you just put like 3?
You could.
1 over 3.
Yep.
You already know what's like going down.
Very good. You already know that square root of 9 is 3. So that gives you, what's 100 divided by 3? It's like 33.
I'm gonna mess up something.
0.33333 forever.
Really? So
That's
it's like the 0.3 and then that thing on the top.
Continues forever. So that's pretty huge margin of error, wouldn't you say? Nine people is not going to give you a good sample.
Wow, I thought 9 was less.
So then you increase the number.
Like 900.
Yes, because this represents how big your sample is. This 9 in here. That's your sample. So the kind of the key behind this is that you got to sample a lot of people to have a little margin of error, and you want a little margin of error because you want to be correct. So that's why. But this is just simple.
But you also want to have a successful, percentage of,
Yes.
I'm sorry.
Well, no, you're good. And one thing you want to think about too, though, is if you're a company, you may not have enough money to sample, 1,000 people or 2,000 people because it costs money to do that or to send out surveys and stuff. So you have to kind of figure out like, well, how much can I spend and be pretty correct? Maybe a margin of error of 5% is okay with you, but maybe some companies are like, nope, I want it to be only 2% because I really want to know. Okay. So guys, let's actually do this one. So now let's just go backwards and then that way we can wrap it up. So we already know the margin of error on this, right? 4%. So we did some sample and it's 4%. What we want to know is how many people did we sample? Okay, so this is why I say going backwards because you just plug it in. So our margin of error is 4% or 4. And we said that was equal to 1 over the square root of our sample size times 100, right? So this, for some reason, always confuses people how to calculate this, but don't let it confuse you. So what I would do first is get rid of that 100, just because it's out on the side. So do you guys know how to get rid of it?
Cancel it out.
Yep, you cancel it out. So what would you do? We're multiplying by 100, so how would you cancel it? Ah, divide. Very good. So we would divide by 100. So if we divide 4 by 100, then we would be good. So these then will cancel.
25.
You're actually on the right track. You just are doing 100 divided by 4. But that was pretty good math there. That was good. So we have 4 over 100. Let's reduce that. What is that, like
Oh my gosh, why?
2 over 50, I think, if we reduce it, equals 1 over n, square root of n. So here's where everybody always gets confused, because they're like, what do I do? This is so confusing. Well, what I would do first is go ahead and put this in your calculator, this 2 over 50, because, that's confusing. And I think I did somewhere. And I got 0.04%. So we'll just go this way. So you get 0.04 is equal to 1 over the square root of n. So we're trying to solve for n. So here's a little flip that you can do. If you have something on the bottom, you can cross multiply, right? So if you cross multiply, you can just switch places with these two. So what ends up happening is you get square root of n is equal to 1 over 0.04. So when you cross multiply, that's what you end up getting, because you think about 0.04 is over 1. So you get 1 times 1, 0.04 times square root of n, and then divide both sides by 0.04 to get that. So it's just a shortcut.
Yeah.
Are you guys all good with that shortcut? Emma, are you good with that shortcut that I did? If you have a variable if you have a variable down at the bottom, normally, since you're dividing, you would have to multiply. And here, let me just erase my shortcut really quick to show you guys. Erase. Going to erase my shortcut just so that you guys can understand it. If you want to solve this, what we normally have to do is, oops, I'm on my eraser. Darn, on the eraser. How did that happen? I know.
Yes.
So this was 1 over the square root of n. Very sloppy now. But anyway, so to get rid of division, you guys agree you have to multiply? Well, what we're actually doing is getting rid of the square root of n, because it's in the denominator. So we had 1 over the square root of n, so 1 divided. So what we want to do is multiply both sides by square root of n. So am I good? You're good with that? So what that happens is then our square root of n's cross out on that side. And we end up with the square root of n times 0.04, and I just put those in parentheses so you guys can see it clear, equals 1, right? So what do we have to do now to get n by itself? How do you get rid of that 0.04? You would have to divide again by what? 4.
4 by square root. Or is it the other?
So think about, you want to get n by itself.
Oh no, you do it 0.04 by 1, right?
So think about this.
All these numbers.
So look at this, you guys. This is multiplication, right? It's like if you have 2 times x and you want to solve for x, how do you get rid of the 2? You divide, right? Always do the opposite.
Okay.
So we want to get rid of the 0.04. So what we're going to do is we're going to divide by 0.04, which means you have to divide the 1 by 0.04. So then those cancel, and now what you're left with, and we'll do another one. We'll do one more so you guys can see. So what you're left with is square root n equals 1 divided by 0.04. Okay, and then I would just put that in your calculator, 1 divided by 0.04, because fractions drive people crazy. And you get 0.25, I believe. Now let me ask you guys this, because now you're core free. Free? You're free. You're free.
Please.
You're core 3.
I was gonna say.
How do you get rid of a square root? Do you guys know how to undo that? Anyone remember? Jazz says no.
I don't
Okay, so when you're taking the square root of something, the opposite of taking the square root is to square it.
Square it.
By
Square
itself,
it.
yeah, it's in square.
And if you do
Square.
something to one side, you have to do it to the other side. So think of it this way, like before, remember how I said the square root of 4 is 2? If you square 2, you get 4. You get back to what you had. So kind of like multiplication and division are opposites. Taking the square root and squaring are opposites too.
Yeah, okay.
Okay, so anyway, once you guys do that, then you're pretty much done because the square root and the square eliminate themselves, and you're just left with n. And so you get n.
Equals 2.5. Well, no.
0.25 or 25 squared. Oh, it's not 0.25, it's 25 squared. Sorry, guys. It's 625. Yeah, that's actually our answer. That's quite a messy problem we have here. And so it's actually, yeah, it's not 0.25. I don't need that 0.25.
Oh, is it,
Ah. Oh. All right, you guys. Sorry about this.
is it 0.65?
It would be, except for that it's just 0.25, and so I mean it's it's
2.5.
25. It's 25,
Oh, 25. Okay.
and so 25 squared is 625.
Oh, okay. Oh, yeah.
All right. So here, I'm gonna try to fix that on here. Okay, so let's actually do the last one just to help you guys out a little bit. So that's just 25. Okay, so again we have a margin of error of 3.5. Okay, so we put that on the outside. And as long as you guys can set this up, that'll help you too. So it's 1 over square root of n times 100. So what's the first thing we get rid of? What did we say?
100.
The 100. So how do we get rid of it?
No, divide.
Divide. Good. So we're going to divide by 100. Yep. And that means we're going to divide this side by 100. Okay, so we're pretty good to go. If we divide 3.5 by 100, we get 0.035. Okay, equals 1 over the square root of n. And do you guys see why our little trick is almost easier because you don't have to go through all that work we just did?
Yeah.
That confused you guys even more?
Yeah.
So if you think about 0.035 as being over 1, what we can do is we can just switch places with those two. So you can do that anytime you have a variable on the bottom because that's what will end up happening because that's what happened over on that last problem. So if we write our new problem out, we get square root of n, there's an n in there, equals 1 divided by 0.035. So now it's easy to solve. We can put that in our calculator.
I can see it. Oh, there you go.
Can you see that? So if we put 0.035 in the calculator, what I got was 28.57. All right, so let me ask you guys again.
Square.
Yes, you must square both sides to get rid of that square root. So if we square that side, then we have to square the right side. And we are left with just n. And I did put this in my calculator for you guys, so you wouldn't have to, but you get approximately 816. And that's our answer for that. So this is definitely a little bit harder because we're going backwards.
Yeah.
I screenshotted this and put it in my email.
Oh, very good. Very good, Jess.
I'm smart like that. Did you taught me that?
I know. See, I taught you before. So anyway, you guys, so it's kind of nice because at least you have these as examples, and even though it is a little bit more difficult to go backwards, write out the problem first, and then just solve it step by step. And if you get stuck somewhere, just come talk to me or submit it, and then we can go through it and you can resubmit it. You could try it again. All right, you guys, so that concludes today. And, Jess, what are you doing over there? So today you should hopefully have a better understanding of standard deviation. And I know you didn't come for that lecture, Donovan, and you should also understand the importance of sample size as it relates to margin of error, right? Bigger sample means lower margin of error. And then finally, you should be able to calculate your margin of error as well as your desired sample size. That was when we went backwards to obtain a certain margin of error. Okay. And just a little note I made for you guys, this week when you start accessing your lessons, you have to do them in order, and it'll give you a little check mark when you've
Why do
accessed
you guys
it.
do that this year? It's so
I think it's.
Trying to help you guys.
yeah.
I think it helps out a lot.
Yeah.
I don't do it in order.
Jazz likes to do them out of order. But at least you guys, you can make sure you get always all the lessons. So that does conclude our webinar, and I hope to see you all next week. Emma, it's good to have you. And we will talk to you guys all next week unless anyone has a question or a comment or they need help. Or if you didn't like the webinar, just let me know. And we're still going to do another one. See you next Tuesday. I might be emailing you for help. Oh, sure, no problem, Emma, no problem. And just know, you guys, that all these lessons are also in the week too. So this is just a little extra to kind of get you going. But like I said, you should be able to view some lessons within the week as well. So, but definitely email me. I'll be at Gateway tomorrow, and I'll be back here on Thursday. So we'll see you all later. Okay.
Yeah.
Oh.